Hello, everyone. This is Shauna, and I'm coming to you today with some homework help for chapter 5 in your textbook. We're going to be doing probability distributions. So I'm hoping to help you get started with that. This section is pretty straightforward. I think you'll find it easier than some of the previous ones. Anyway, let's get on with it, shall we? So just a little bit about probability distributions before we actually start the homework. There's going to be some definitions in here, like always. So we need to remember what discrete variables mean, okay? Discrete variables assume values that can be counted. So these are values that are whole numbers generally. So the number of faculty members at Cerritos College, the number of cars in a parking lot, the number of houses on your street. Those are discrete, okay? Continuous variables have an infinite number of possible values. What that means is that they can take on values between numbers and they continue forever. We measure that. So this could be like the weight of a shipment of packages from Amazon. It could be the temperature outside during 1 month of January in California. It could be the heights of fourth graders in a school in your neighborhood. These are continuous variables. Let's go to the next slide here. A discrete probability distribution consists of values of a random variable. Consists of the values a random variable can assume and the corresponding probabilities. So it's kind of like a combination of the tree diagram with the sample space, but all it shows us is the probabilities and the values that the variable can assume. Now, before we actually see what one looks like, there are two requirements. And we're going to be looking at some problems on the homework that ask you about these. The probability that each variable must be between or equal to 0 or 1. So in other words, it can be between 0 and 1 inclusive. It can be a decimal, it can't be negative, and it can't be more than 1. But the sum of the probability has to equal 1, okay? So let's take a look at this probability distribution here. Determine whether the distribution represents a discrete probability distribution. If it does, state why. If it doesn't, state why not. So you're looking at it. Remember, your two requirements are that they have to, the probabilities down here where it says P of X has to be between 0 and 1. So 1/7 is between 0 and 1. 3/7 is between 0 and 1, and 2/7 is between 0 and 1. None of these probabilities can be negative, and none of them can be greater than 1. They aren't, okay? And if you add all of the probabilities up in the chart, 1/7 plus 1/7 is 2/7, 2/7 plus 3/7 is 5/7, and 5/7 plus 2/7 is 7/7. So this does satisfy the requirements for a discrete probability distribution. So let me, without going too far into this, let me show you the homework assignment here. Okay, so the first part is define and give 3 examples of a random variable, okay? And then give 3 examples of a discrete random variable. So she wants you to define a random variable, and that's in your book. I'll show you where it is. And then examples. She wants 3 examples of a discrete random variable. I gave you 3 earlier. And she also wants 3 examples of continuous random variables, but here specifically associated with a Major League Baseball game. So I'm going to do something here. I'm going to stop sharing the screen for a minute, and I'm going to bring up another, I'm going to bring up another resource here. Let me just bear with me for a moment here. But discrete variables that could be associated with a baseball game, or continuous variables that would be associated with a baseball game, specifically in that context, could be things like the length that it takes to play the game. The time that it takes to play the game is a continuous random variable. The number, the ounces that the baseball players drink during the game could be a continuous random variable. A continuous variable could be like the pounds of hot dogs sold at the game, for example. So we're looking at those things. I'm going to show you something here from the textbook. Let me just pull up the screen so you can see it. I'm going to pull up the screen share and share the book with you. Hold on. See, here's the book. Okay. So now this is your textbook, and some of these definitions are in your textbook. So be sure you're reading it. Okay. So when she says, for number 1, she says, define a random variable. Here it is. This is the definition of a random variable. It's a variable whose values are determined by chance. Okay? That's what a random variable is. Okay? So, if you roll a die, the value that you get on that die is a random variable. It occurs by chance. If you flip a coin and you get heads or tails, those are random variables. So for example, here, when you write for this homework assignment, let me find it again because I've got a lot of screens open here. Let me find the homework assignment. It asks us for the, okay, here we go. Here's our homework. Define and give 3 examples of a random variable. Now, as we saw, what are we going to put? We're going to put what I showed you in the box. We're going to say that we're going to say that a random variable is a variable whose values are determined by chance. Examples of random variables are, okay, the result of the flip of a coin would be random, heads or tail, right? Could be the number of girls in a family of 3 children, for example. Or we could say the number of let's say science majors in a class that you have, the number of people majoring in science. Those are random variables, okay? Define and give 3 examples. Your examples can be different than mine, but the definition is the same. A random variable is a variable whose results are determined by chance. Now here, we're looking specifically at discrete random variables. So here, this is question 1, okay? This is for question 1. This is what you would say for question 1 here. Now, give 3 examples of a discrete random variable, okay? Well, if it's discrete, remember, it can be counted. So I can say 3 examples of a discrete random variable are. And I mentioned these before. The number of cars in a parking lot, the number of cats in an animal shelter, okay? Or I could say the number of PhD candidate, PhD faculty at a university. Those are discrete variables, okay? Means that you can count them. Does that make sense? That's where we are for that. So that's problem number 2 on your. Okay, so I've given you plenty of examples of discrete and continuous, and I hope you understand what random variables mean, what discrete variables mean. We're going to go on now, and we're going to talk about, hold on. We're going to go on and we're going to talk about some of the actual work in here. So again, 3 continuous variables and 3 discrete random associated with Major League Baseball. I'm going to let you work on that on your own. If you have questions, feel free to email me. There are lots of possible options. I gave you some earlier, but let's go back to what we were talking about here. Discerning whether the distribution represents a probability distribution or not. So remember, our probability distributions have to have values that are between 0 and 1, and they have to add up to 1. The probabilities have to add up to 1. Let's take a look at this exercise 4 here. I'm going to share the screen. Now, here, okay, we've got an issue here with this, because this probability the probability is negative. So number 4 would be no. Number 4 does not represent a probability distribution because the probability associated with 12 is negative. Okay, so I would say something like, you can word this a few different ways. You can say, let me come back and say this. I can say number 4. Let me put it on the whiteboard so it's easier to read it. I can say that this does not represent a probability distribution because the probability of getting 12 cannot be less than 0. Cannot be negative, if you want to say that. So basically my problem is that the probability of 12 cannot be less than 0. So this is question 4 on your screen. Now let's look at question 5. So let me share the screen again here. Let's look at question 5. Question 5. Now, we can have negative numbers at the top for X. We don't know what those represent. Maybe they're cards that you drew out of a hat. Maybe they represent the degrees below 0 in temperature. We don't know what X represents, but X's can be negative. P of X's cannot be negative. So here in number 5, let's look. Do we have any negative probabilities? No. Do we have any probabilities that are larger than 1? No. Now, do my probabilities add up to 1 when I add them up? Well, 0.3. So let's do this. We have, I'll do it for you on the screen here. This is, we're going to do this. We're going to say, I'll do it over here. 0.3 plus 0.4 plus 0.2 plus 0.1. Okay, well, if you add that up, and you can use a calculator to help you, 0.3, 0.4, that's 0.7, plus 0.2 is 0.9. This adds up to 1. So this checks, okay? And so since all of the individual probabilities are between 0 and 1, and the sum of all the probabilities equals 1, the distribution represents a probability distribution, okay? So that is how you would answer that. That's number 5, okay? Does it represent a probability distribution or not? Okay. So we're there. Okay. Number 6, let's look at it. This is number 5. Number 6 says we have 1 with a probability of 0.4. We have 2 with a probability of 0.3. We have 3 with a probability of 0.2. And we have 4 with a probability of 1. Now, what do you think? Yes or no? Take a minute, pause the video, come back, and we'll go over that. Okay, I'm glad you're back. If you clicked away. Is this a probability distribution or not? Well, the probabilities don't add up to 1. They add up to 1.9 if you add them up. So the probabilities are to the sum itself. The individual probabilities are okay, but the sum is more than 1. So 6 would be no. So once again, 4 was no because of the negative probability. 5 was yes, and 6 is no because of the sum. Okay, so 6 does not represent a probability distribution. So you would say no, because the sum of all the probabilities is greater, greater than 1. Okay, so not a big deal there. All right, now 7 through 9 should look very familiar. It looks similar to what we did back in chapter 1. And there's a reason why we're reviewing these concepts. These concepts become important again in this chapter. So they're kind of going back and reviewing it. And then we're going to extend these concepts later in the section, and then in 5.2 and the rest of chapter 5. So let's take a look at these exercises here. We're classifying whether the variable is discrete or continuous. Okay. The number of cheeseburgers a fast food restaurant serves each day. Well, can I count those? Now, there's a difference between can I count them and do I know what the number is? Okay, sometimes students ask me, well, I don't know what the number is, so wouldn't it be continuous? Or they cook them every day, so wouldn't it be continuous? No, we're looking at the number of cheeseburgers, okay? And cheeseburgers, we're going to assume that if somebody comes in and they aren't as hungry as they thought and they only ate half a cheeseburger, that counts as a cheat. It counts, okay? So we're not going to worry about, you're going to make it and you're going to make the whole cheeseburger. So this is discrete, okay? Even if you don't know what that number is, it is a countable number. Now, the weight of an automobile, would you count weight? In which case it would be discrete. Or would you measure weight? Because if you would count it, then it's discrete. If you would measure it, then it's continuous. This is a continuous variable, okay? The number of mathematics majors in your school, we went through something similar earlier. This is discrete. So those are there for you if you need it, okay? Now, we want to decide, I believe here we're looking at whether we have a discrete distribution or not. Let me check the textbook because she seems to have blocked out the instructions. So let me check the textbook here. Let me go and stop sharing the screen. And we'll go back to the textbook briefly. And we'll see if we can figure out what's going on. So, let me see. And I don't have it open. All right, let me do this. Let me go to, here it is. Okay, now let's do this. Let's pull this open. And we're going to share the screen here. And I'll take you down and we'll look at the okay, so we've gotten past the, oops. We've gotten past the, okay, there's my book. Here's my exercises. Yeah, what we're doing is we're looking at we're in number 10 here, and we're going to, for exercises 7 to 12, determine whether the distribution represents, yeah. So whether it's described as a distribution or whether it is continuous or not, we're going to look at that. So let's look at our distribution here. We're gonna change our screen share and go to the homework here, and we're gonna click out, and we're gonna pull the distribution out. Stop sharing this and start sharing the, one moment, folks. Okay. So what I'm going to do is homework here. All right, so now we're looking at this. And the probabilities that a patient will have 0, 1, 2, or 3 medical tests are 6/15, 5/15, 3/15, and 1/15, respectively. So what we want to do is actually construct the distribution, okay? So the probability that a patient will have 0, 1, 2, or 3 medical tests performed on entering a hospital. So we're going to say this. You're actually going to construct what you've seen. So we're going to look at question 10 here. Question 10. Question 10. And what we're going to do when you construct a probability distribution, you're going to draw a line, give yourself some space, and you're going to make a line here. On this top, you're going to put X, okay? And you're going to define because Professor Nickel requires that you define this, okay? So we're going to define our X, and then we're going to put our P of X down here, okay? Now we have to either be able to get the probability or they have to give it to you. Sometimes it's a situation and you have to find these, but here, I believe they gave them to you. So let me just put some lines in my distribution here, and we'll see where we're going with this. So let's return to our exercise. It says, the patient will, that probabilities that a patient will have 0, 1, 2, or 3 medical tests performed, okay? So this is X is the number, this is the number of tests, okay? And what we're going to do is we're going to have 0, 1, oops, 2, oops, or 3 medical tests performed, okay? 0, 1, 2, or 3. I don't need this line here. Okay, so now I'm going to put the probabilities underneath. So now they, in this case, they give them to me. So I'm going to put them in where they belong. Okay. 6 15s, 5 15s, 3 15s, and 1 15. Okay. So you're going to put 6 15s, 5 15s, 3 15s, right, so just a bit, there we go, and 1 15. So I'm going to have 15. And I think she left these unreduced, so you could see something. 6 plus 5 is 11. 11 plus 3 is 14. This is 15. This adds up to 15 over 15, which makes this a true probability distribution. So what you've done here is construct a probability distribution to describe the situation that's given to you. And that's what you're going to be doing for the problems that follow. So I did number 10 for you. I'll leave you to do number 11 and 12. Now, notice she gave you different probabilities on 12. That's because the die is loaded, okay? What that means, we're used to using a fair die, and a fair die means that all the outcomes have an equal chance of occurring. If it's loaded, some outcomes are more likely than others. Usually what they do to load a die is they shave it a bit. They shave it a bit on one side to make it heavier on one side than the other and make it more likely to fall in a certain way. So here, she's giving you different probabilities, okay? Don't panic, okay? If you add them up, they should add up to 1. You're gonna have to do a little bit of work there to see that, but all you're gonna do in problems 10 through, let's see, I think 10 through 15. Yeah, all you're gonna do in 10 through 14 is create the probability distribution. So I'll leave that for you to do on your own, but I hope this overview has helped you, and I'll show you too where you can go for more help, but this, the way that she wants the probability distributions, let me share the slides. Let me go back to the PowerPoints. Hold on. We're going to go back to power, which there they are. Okay, let's take a look at this really quick. So we saw that for the first part of the homework, we did discrete variables, continuous variables, requirements for a probability distribution, graphing a probability distribution, constructing it. So this is what you're doing in 10 through 15. Here's your information. You write out a label for this, you put key, you write it underneath, and you graph it. Graphing it requires that you just place your X values on the X-axis, and then your Y-axis is your percentages, okay? Now, sometimes, like in example 5, she doesn't give you the probabilities. You have to find them yourself and then put them in. So that's some examples of that. But I'm going to leave those for you. If you need any additional assistance, you can feel free to reach out to us. But I think this section is pretty straightforward. Good luck. And I will see you in my next video. Thank you very much for watching. Bye for now.